So hi everyone. So in this video we are going to solve another recursion problem, that is finding a power of given number. Okay. So what problem says we have been given, that is x. Okay. Let's suppose it's 2 and we have been given as power to calculate, that is 5. So how you calculate 2 to the power 5 is you will be multiplying 2 5 times. Correct? So the answer will be 32. So you have to return 32 as answer. Okay, so let's try to build the recursive solution for this problem. Okay, so in the previous video we have see that I have designed one framework. It involves 4 steps. Okay, so we are going to follow that step again. That is, first step is find out the base case. Okay, so let's try to find out the base case. If I want to calculate 2 to the power 5, what I need to do is I have to multiply myself with the sub problem result, that is 2 to the power 4. Okay, if I have to calculate 2 to the power 4, I will multiply myself with the sub problem, that is 2 to the power 3. Okay, if I want to calculate 2 to the power 3, then I will multiply myself with the sub problem 2 to the power 2. If I want to calculate 2 to the power 2, then I will multiply myself with sub problem 2 to the power 1. If I want to calculate 2 to the power 1, then I will multiply myself with the sub problem 2 to the power 0. What is 2 to the power 0? The smallest problem, I can say the smallest sub problem in this whole problem is 2 to the power 0. Correct? Because beyond this we cannot go. We cannot go 2 to the power minus 1. Correct? So 2 to the power 0 is going to be 1, because this is called as a power identity, right? And any number based to any number having a power 0 always going to be give 1. Correct? So 2 to the power 0, we got the smallest sub problem exists in my whole problem. Okay, so this is going to be my base case. Correct? Fine. Now let's move to the second step. Build a visual example. Okay, now I need to build a visual example for this. Okay, so let's try to build one visual example for this. Just randomly I'm making, let's suppose I need to calculate 2 to the power 5. Okay, randomly I'm making a 5 box. Okay, fine. 2 to the power 5. For 2 to the power 4, randomly I'm making a 4 box. Okay, for 2 to the power 3, randomly I made a 3 box. For 2 to the power 2, I made 2 box. For 2 to the power 1, I made 1 box. And I know the answer of 2 to the power 0 is 1. Okay, so what is the formula to calculate the power? The formula is, if I want to calculate 2 to the power 1, I will multiply myself with the result of 2 to the power 0. Correct? What is 2 to the power 0? That is 1. Fine. Okay, I will just copy 2 to the power 1 answer here. Okay, that is 2 to the power 1. Oh, sorry. 2 to the power 1 is going to be 2. Okay, because 2 to the power 1 I got 1, and 2 into 1, that is 2. So I will copy paste here 2. What is 2 to the power 2? I will calculate myself with 2 to the power 1. Fine. So what is 2 to the power 1? That is 2. So 2 into 2, that is 4. Fine. I will simply copy paste this. Okay, if I want to calculate 2 to the power 3, then I will simply multiply myself with the sub problem. Result I got, that is 2 to the power 2. So 2 to the power 2 is 4. I will multiply it with 2, that is going to be 8. Fine. If I want to calculate 2 to the power 4, then I will simply multiply the result of 2 to the power 3. Okay, so I have just simply copy pasted this value, and I will multiply myself with 2 to the power 8, that is going to be 60. Okay, now if I want to calculate 2 to the power 5, okay, so what I can do is I will multiply myself with the sub problem result, that is 2 to the power 4. Okay, so 2 to the power 1 is 2, 2 to the power 2, that is 4, 2 to the power 3, that is 8, 2 to the power 4, that is 16. So this result we have, I will multiply myself with that, that is going to be 32. I hope you understand this diagram. Now let's move to the next step, that is find a relation. Find a relation. Okay, so relation is very simple. If I want to calculate 2 to the power n, the relation is I will multiply myself with the result of sub problem, that is 2 to the power n minus 1. Correct? So this is the relation. If I want to calculate 2 to the power n, find out the relation, find out the result of 2 to the power n minus 1 and calculate and multiply yourself with that result, and you will get the result for the whole problem. Okay, so let's move to the last part, that is code it. Okay, so how can you code it? So I have a base case that is defined as if 2 to the power 0 I have 1. So if power is 0, I need to return as 1, that is 2 to the power 0 equal to 1. So let's code it first. Base case, if power, okay, I given as I make a variable p. If p is equal to 0, then I need to return 1. Fine. Else if p is not equal to 0, then what I need to do is I will make one result. This will store the result of the sub problem. Okay, and I will call the power function. Okay, I will call the power function by passing, I will pass x as it is, there is no change in x. Okay, but I will pass n as n minus 1. Okay, so the problem is okay, let me first make this void power function. Okay, it will take two variable, that is one is x, and it will take one more variable, that is going to be p. Okay, fine. So the problem here is I got the result of my sub problem. Okay, now I will return by multiplying with myself, that is x, and the result of sub problem. I will return this. Fine. So we have coded it step by step. I have shown you that we have defined the base case. So I wrote first base case. Next, if the power is not equal to 0, then what we need to do, we have to calculate the result of sub problem, and once we have calculated that, I will multiply with myself and return the whole result. Okay, so let's move to the IDE and try to debug this once. Okay, so I have prepared one template for this. Okay, so what I need to check is I will check if power, or I can say p, is equal to 0, then I need to return what? I need to return 1. Fine. If it is not equal to 0, then what I need to do is I will calculate result of sub problem. Okay, so I will call calculate power. I will pass, okay, there we have given the name as x, so I will put as x on. Okay, so I will pass x as it is and power equal to n minus 1. Okay, Once I got this result, what I need to do is I will multiply x with the result which I got, and I will return that. Okay, so let's try to calculate for 2 to the power 10. So for 2 to the power 10, I got answer as 1024. That is correct. Okay, so let's try to debug this. Okay, power is 10. Okay, so you need to focus here. Okay, so main function has called calculate power by passing x as 2 and power as 10. Okay, let's go there. Fine, the power function has been calculated. The calculate power function has been called by power is equal to 10. Okay, so here power is equal to 9 is there, so it will move in the linear way. Okay, so it will calculate power of 9, then it will calculate power of 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, and at last when it will come to 0, it will return as 1. It will return as 1 to the where we have called the power as 1, where we have passed power as 1. Okay, so I got the result there, and I will calculate the power of 0. Okay, so it gave me the result as 1. Okay, I will multiply myself, that is 2, and it has the answer that is going to be 2. Okay, so I got 2. The sub problem was 2 to the power 1. Okay, I will multiply myself and return the answer. Same thing happened for 4 also. For power is equal to 3, I will multiply myself and return the answer. Okay, same thing is going to be happen until we'll come to the 2 to the power 10. Okay, so this is my first call I have made for 2 to the power 10. Okay, so for 2 to the power 10, I need to calculate 2 to the power 9. So I got 2 to the power 9 as 512, and I will multiply myself and I will return the answer, that is 1024. Okay, so I hope you understand this code. Okay, so this, if you understand this code, no, actually this code will work fine, but sometime in interview they will ask to optimize this code. Okay, so let's see the optimized version of this code. Okay, so let's see the optimized version of that code. Okay, so let's see optimized version of that code. But before moving to the optimized version, let's analyze the tree of the previous code. Okay, recursion tree. For 2 to the power 5, if I want to calculate, then what I need to do is I need to calculate 2 to the power 4. I need to calculate 2 to the power 3. I need to calculate 2 to the power 2. I need to calculate 2 to the power 1. I need to calculate 2 to the power 0. So it will go linearly. Okay, suppose if you want to calculate 2 to the power 100, no, it will go linearly to 99 blah 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 2 to the power 0. Okay, it will go from 0 to 100. It will make a stack call. Okay, but I think this is not needed. Okay, this is not needed. Why? If you see, we have one mathematical formula, that is, let's suppose we want to calculate 2 to the power 5. There is one formula where this is x. Okay, where x is 2 and p is 5. We have a mathematical formula that if p equal to even, then we can calculate power is equal to 2 to the power n minus 2 into 2 to the power n minus 2. If p equal to odd, then we can calculate is, how we can calculate is 2 into 2 to the power n by 2 into 2 to the power n by 2. Let's check this. Okay, I want to calculate 2 to the power 5. 5 is, we need to check this, 5 is odd. Okay, so 2, okay, n by 2, 5 divided by 2, that is going to be 2. Okay, 5 divided by 2, that is going to be 2. Okay, so 2 to the power 4, because in maths what happen is that power is going to be get plus if the base is same. So 2 to the power 4, and at last it's going to be, because it has a power as 1, so 2 to the power 5. Okay, so this is how we are going to code it now. Okay, so this is the optimal way, because if you see the recursive tree for this, for 2 to the power 5, I need to calculate 2 to the power 2, 2 to the power 2, then 2 to the power 1, then 2 to the power 1, and we'll make one more call, 2 to the power 1, 2 to the power 1. But in previous code, no, if we want to calculate 2 to the power 5, then we have to calculate 2 to the power 4, 3, 2, and 1. Okay, so how much call we are making here is 5 calls we are making. And call in the sense how much depth recursion it's going is 2 to the power, I mean 5 level is 5, but here the depth level is only 3, correct? So this is the more optimal way to code it, to find the power. Okay, so let's try to code this. How we can code this? So recursion base case is going to be same. Recursion diagram I have shown you above. Okay, only the thing is going to be changes code. So let's build this. I have a base case, the same, the power is equal to 0, so return 1. Fine. Else what I need to do is I need to check if power modulo 2 equal to 0, then I will make here one variable that is result, and I will assign value as 0. So result will be power of modulo power of I can say p divided by 2. Sorry, I need to pass, and also right, I need to pass x as it is and power by 2 into power x as it is and power by 2. Okay, fine. Else if it is not equal to 0, that means it's odd. Okay, so I will calculate res equal to same x p divided by 2 power x as it is p divided by 2, and once I got result, I will multiply that result with x again one time, and I will calculate the result, and this I am going to return. Okay, so this is going to be my power function. Okay, so it will take one variable x, one variable power. Okay, so same thing in the previous code we have done, like base case was same. Here only we have discussed if power modulo, if it is even, then we will calculate the power by calculating half of that power, and if it is odd, I will calculate half, then I will multiply again 1, and I will calculate the result, and I will return that. Okay, so let's move to the coding part and try to analyze there using the debugger. Once we have debugged that, we will try to understand using the recursive tree. Okay, so I have made the input small, so I want to calculate for power 3. Okay, so I want to calculate for the power 3. So let's try to debug this. Okay, so what is going to be happen for power 3? It's not equal to 0, and it's not equal to even, so it is going to come to the else part, and this for this we are calling power function 2 times. So the left side, first left side is going to be called, then once we got the result from the left side, right side is going to be called. Okay, so this is left side got called. So previously we had a 3 divided by 2, that is 1, so we came for the 1. Okay, 1 is also odd, so 1 is calling for 0, we got 1 as a result. Now we have calculated left side, now right side is going to be calculated, and from there also we got 1, so 1 into 1 we got result as 1. Okay, so as p1 is odd, so we need to multiply x once, so after multiplying we will, so 2 into 1 we will be getting as 2. Okay, so this, okay, now tell me this result where it going to be written. This is going to be written for p equal to 3, which is left side. Fine. Now we got the result of this part. Okay, we got the result for this part. Now right side will make a call. Okay, so again for p equal to 1, p is not equal to 0 modulo, so we came into else part and I have called left side for p equal to 0. I have got answer as 1, right side answer as 1, and after calculating 1 into 1 the result is 1. As p was odd, I will multiply x once, so 2 into 1, that is going to be 2. So left and right I got answer as 2, I will multiply both, it will become 4. As you can see, as 3 is odd, so we'll multiply x with that. Okay, so 2 into 4, that is going to be 8. So we are returning 8 as answer. So this is how we have tried to debug this code. So let's move to the recursive tree and try to understand the recursion, how recursion work for this problem. Okay, so let's try to analyze the recursion tree of that optimal code. Okay, so we want to calculate for 2 to the power 3. Fine. So to calculate 2 to the power 3, what our code says is, as 3 is what? 3 is odd, right? So whatever answer I got, I will multiply with 2. Okay, so before that I need to calculate the result from its sub problem. So how I'm calling the sub problem, that is x will be same as it is, and p divided by 2 multiply by power function I'm calling x as it is, power divided by 2. So 2 call I'm making left and right, so I'm making here. So 3 divided by 2, that is 1, so 2 to the power 1. Here also 2 to the power 1. Okay, so 1 is what? 1 is odd, so I need to, whatever the result I got, I will multiply with 2. Okay, 2 to the power 1 will call 2 to the power 0 from in left and right. Okay, here also same thing is going to happen. Fine. Okay, now the next thing is, this is our base case, so it is going to return 1, correct? So we got 1 from here. Okay, so from left and right, once we get the answer, we need to multiply them. So 1 into 1, that is going to be 1, correct? As 1 is odd, so whatever result I got, that is 1, I need to multiply with x, that is 2. So 2 into 1, that is going to be 2. Okay, so here I will return 2. Same thing here also, as 1 is odd, so whatever result I got, that is 1, I need to multiply with that, that is 2, so I need to return 2. Okay, so I got from left side I got 2, right side I got 2. From here I can say that I need to multiply both left and right side result, that is after multiplying I will get 4. Fine. From 2 from here, 2 from here, 2 into 2, 4. Okay, as 3 is odd, so what I need to do, I need to multiply extra x with my result, that is 2 into my sub problem result, that is 4. So answer is 8. Okay, so this is how the recursive tree of the optimal solution is going to work. Okay, so I hope you like this video. Till then, take care, bye bye.